All right, this is the 5th FRQ from the 2019 BC exam. So first they say to find the slope of the tangent line so that it equals 6, so we need to find the value of k. So f of x litter box. The derivative, we've got low d high minus high d low divided by low squared. And we know that the slope at x equals 0 is 6. So f prime of 0, that's nothing. So I've got negative 2 times 0 minus 2, 0 squared minus 2 times 0 plus k squared equals 6. That's nothing, that's nothing. So I've got positive 2 over k squared equals 6. So 2 over 6 equals k squared. So 1/3 equals k squared, and k is the square root of 1/3, and you can, and it would be plus or minus, but they said positive k value, k is greater than 0. You can rationalize that, but you don't need to. You can just leave it as square root 1/3. That's totally fine. All right, part B. This one, when I was doing it, really messed with me. I think they were kind of rude for doing this, but so they give you k is -8. So x squared minus 2x minus 8, partial fraction decomposition. So you have 1 over x minus 4, x plus 2, a over x minus 4, b over x plus 2. And then if I multiply the whole thing by the denominator to solve for a and b, I get 1 equals a times x plus 2 plus b times x minus 4. If I use x equals 4, I get 1 equals 6a. So a equals 1/6. If I use x equals -2, I get 1 equals b, -6b. So b equals -1/6. And so I was solving the integral from 0 to 1, and what I did is I said, okay, this is positive 1/6, this is -1/6. I kind of pulled those out in the front as like a coefficient, and then I said that would leave me with 1 over x minus 4 minus, because that one was negative, 1 over x plus 2. All right, and so from there, what it leaves me with is 1/6 ln x minus 4 minus ln x plus 2, evaluated from 0 to 1. And then if you use property of logs, you have 1/6 ln of x minus 4 over x plus 2 from 0 to 1. And so what you do next is you're plugging in the 1, and what I noticed, and this is the part that messed me up, is that you get ln of -3 over 3, and I was like, oh, you can't take the ln of a negative. However, this isn't an absolute value sign, so that's actually ln of 1, positive 1. So that, I did not pick up on that until I looked at the answer key, and I was like, oh, dumb, I can't believe I missed that. Because typically in these problems, that doesn't happen. They give you something that you can plug in without a negative, and the absolute value sign didn't matter anyway, but here it actually matters. So you get 1/6 ln 1 minus ln 2, and so that's 1/6 ln of 1/2. And the answer key does not have this. It has, what they did in the answer key is they said 1/6 ln of 2 to the -1, and then they brought the -1 to the front. So it was -1/6 ln 2. But 1/6 ln 1/2 is still the right answer. It's just a different form. So whichever answer you have there is totally fine. All right, and then for part C, they said have k equals 1. And so what I did there is I factored it, and I saw that was x minus 1, x minus 1. And you don't really need partial fraction decomposition for that. You can just say that's 1 over x minus 1 squared if you want to integrate that. And so you have the integral from 0 to 2. And then you have to be careful because you have to realize that this is not continuous at 1. So you actually have to split this up. And you have to say the integral from 0 to 1 plus the integral from 1 to 2. And it's 1 from the left, 1 from the right. So in here, you can use U substitution if you want. You don't have to use U substitution because the derivative of the inside is just 1. So what I was thinking of this as is like 1 over U to the second, which is U to the negative 2. And if I integrate that, then I get negative 1 over U. So this is negative 1 over x minus 1, evaluated from 0 to 1 from the left. And then negative 1 over x minus 1, 1 from the right to 2. And when you're evaluating this, you have to be careful because you have a number you can't technically plug in. You can't plug in 1 minus 1, and so this is where you have to do limits. So I said the limit as c approaches 1 from the left and then limit as d approaches 1 from the right. And that's, I guess I can do, oh, I shouldn't have said 1 from the left, I should have said C. Limit as D approaches 1 from the right, negative 1 over 2 minus 1, minus negative 1 over D minus 1. So what happens here is you get, if you have 1 from the left, that's like 0.99999. So you have a 0 on the bottom that's slightly negative. So you have a negative 1 divided by a 0 that's slightly negative. That's a positive infinity. Minus 1 plus negative 1. And then your d value is a positive 1. So this is a slightly positive 0, positive 1 on the top. So that's another positive infinity. And then because of the infinity, you have to conclude that this diverges. And I don't know that I would necessarily leave the infinity on the page. You're probably okay since you're not plugging it in, but I'd maybe scribble that out just to be on the safe side.